All right, let's look at number 8. What types of bonds are present in an ionic compound that contains a polyatomic ion? Okay. Now, before we just answer this off the top of our head, let's try to make sure we understand what situation we're talking about. In the notes, I introduced you to a molecule called sodium phosphate. It looked like that. Okay. Now, there are two individual sodium ions. Okay, there are two of these. And there's one of these sulfate ions. And this acts as a unit. This does not behave as an individual sulfur atom and then 4 individual oxygen atoms. They act as a unit. They're a little gang together. Now, we can represent this using Lewis structure, just like we've practiced before. Valence electrons, valence electrons, valence electrons. All right, it looks like this. Okay, it looks like this. And overall, this has a -2 charge. Boom. So we have a positive ion, negative ion attracting each other. So what type of bond are we going to see in this ionic compound? Well, we're going to have ionic bonding between sodium and sulfate. Okay, that's pretty straightforward. It's an ionic compound. You're going to have ionic bonding. But when we look at this sulfate unit by itself, the sulfur to oxygen bonds within the polyatomic ion are covalent. Both sulfur and oxygen are nonmetals, and the vast majority of the time when we look at nonmetals bonded with nonmetals, it's going to be a covalent bond. So not only do we have the ionic bond between the sodium ion and the sulfate ion, we also have covalent bonds within the sulfate ion. Okay, so we actually have both types of bonds here. Okay, let's look at number 9, and this is very similar to a question that you guys had on your previous worksheets talking about bond energy, and it's going to be a very, very similar process for figuring this out. Arrange the ionic bonds in the table below in order of increasing strength from weakest to strongest. Well, weakest is going to be represented by the smallest magnitude of a lattice energy. So this is the number one smallest number I can find. Actually, I'll just start writing the compounds. KCl. The next smallest is sodium chloride. The next smallest is lithium chloride. Let's see, next smallest is calcium oxide, and so that will leave magnesium oxide for the strongest bond here, the largest lattice energy.